Hello. In this video, we're going to be verifying trigonometric identities. So what that means is we're going to have an equation with two or more trig functions on each side, and we're going to have to show that they're actually equal to each other. So some guidelines before we begin. First of all, we're only going to work with one side of the equation. In this case, since we're unsure if they're equal, or we haven't been guaranteed that they're equal, we cannot add or subtract things onto both sides. That only works in a true equality. Number two, we're going to use the fundamental identities, so if you need to refer to those, keep a list handy when we're working on these. And then number three, if possible, we can look to factor, add fractions together. If a binomial is being squared, we can do that. If it's easier to simplify the denominator, we can do that too. So, in my example here, we're asked to verify that cosecant squared of x minus 1 all over cosecant squared of x is the same as cosine of x. Now there are a couple different ways to go about this, so let me do one with you and then I'll do another. And so first thing I want to notice, cosecant squared of x minus 1 is the same as cotangent squared of x. So I'm going to replace here cosecant squared of x minus 1 with cotangent squared of x. So we get cotangent squared of x over cosecant squared of x, and we're trying to show that that's the same as cosine squared of x. Now cosecant is the reciprocal of sine, so we should be able to turn this cotangent squared of x into times sine squared of x, still equal to cosine squared. And that is because 1 over cosecant squared of x is equal to sine squared of x. They're reciprocals. Cotangent, since I'm in red here, cotangent squared is the same as cosine squared divided by sine squared. And so I can turn the cotangent squared into cosine squared of x divide sine squared of x times sine squared of x equals cosine squared of x. Now we notice that sine squared divided by sine squared is 1. They would cancel each other out, and we come up with that cosine squared of x equals cosine squared of x. And all we did to get to that step was to simplify by crossing out our cosine squareds of x's. Okay, that's one method we could use. So let me draw a line down here. Let me try another one. We know that cosecant squared of x minus 1 over cosecant squared of x can be rewritten. So I can rewrite this into cosecant squared of x over cosecant squared of x minus 1 over cosecant squared of x. So we just split this up into two fractions instead of one. We have our common denominator, so that's okay. We're showing that that's equal to cosine squared of x. Cosecant divided by cosecant would cancel and become 1 minus 1 over cosecant. We already showed you right here was the same as sine squared of x. And because of our Pythagorean identity, that sine squared plus cosine squared equals 1, 1 minus sine squared would be the same as cosine squared of x. Okay, and so we were able to show it that way as well. So there are multiple different ways to show or to verify an identity is true. We'll do more of these in class. For now, we're done.